Assalamu alaikum, girls.
Walaikum assalam, Miss.
How are you doing, all of you?
Alhamdulillah, Miss. Miss Ramadan Kareem.
Ramadan Kareem. Is it possible? Is it like that? We're going to have first Ramadan tomorrow or day after tomorrow?
I think it's on Friday, Miss.
I think so. Inshallah. It might be. Means tomorrow we are going to have the first Tarawih. Right? Yes. Okay, fine. Inshallah.
Yes, Miss.
Okay. So I can see students are still joining. So now you tell me, girls, how far I have finished with you in my last class. I remember I was doing the past paper questions with you. And I have already provided you the notes of electromagnetism, the first part. Isn't it, girls? I hope all of you got the note. I gave it on the WhatsApp group. Did you check the note?
Yes, Miss. Miss, I
Yes.
asked you, Miss, to send page number 2 again because there were some words which were not clear.
Okay. Now, okay, I'm gonna check with that. Don't worry. But first, you tell me. Hopefully, I have finished all the questions for current electricity till 2019. Did I? I don't remember actually. Dear, could you help me?
I don't think Miss 2019 we finished.
Which year I have done in the last class? Could you remember? Anyone from the class?
Just a minute, Miss.
Yes, dear.
Yes, I think 18 and 19 is left.
18, 19 left. Okay. Now you tell me one thing, girls. Do you have 2019's paper with you or 18's paper with you now?
Miss, I have both.
Okay. How many of you are having? Means I want to do it today or I can do it on next class. But you have to have it with you because I know 19 papers you have to download and take a printout. Then only you can do. So what do you say? Shall I do it now or I'll be doing it tomorrow with you? You tell me, dear.
Miss, can I do it tomorrow? Because everyone's not having 2019's paper.
Okay, but 18s do you have? I think most of you.
Yes, Miss.
Okay, most of you have
Yes.
18 with you. Okay, so shall I do 18 today and 19 tomorrow? Then I can teach you some parts of that electromagnetism as well. What do you say, guys? Could you check
Sure,
18?
Miss.
18? Yeah, sure. So quickly, okay.
Miss?
Yes, dear.
Are we done with electromagnetism's notes?
No, dear. It's only the first part. We have a second part as well. It's a big chapter. It's a whole chapter here. So the first part that I gave you, you just keep on writing. And hopefully next week I'll be providing you the next part of the note. But let us take now 2018 questions. As you said, I didn't do it because I actually don't remember what I did because it's a gap between the two classes that I had with you last week. Okay. So let's go to 41, May, June 18. All of you please go to that question. Okay. Now, all of you go and check. Let me see what do we have here. Okay. Okay, guys, 41, May, June 18. Actually, we don't have any question at this moment from current electricity. No, we have one. Yes. Okay, we got question number 7 there. Could you just go to question number 7 of 41, May, June 18? All of you, please. 41, May, June 18, question number 7. All of you check. Okay, today I can see that Luzane is present. Luzane, how are you, dear? I think this is the first time I have you in my class. Luzane, could you answer me? Hello. Right, girl?
Should we repeat the variant again?
Yes, dear. 41, May, June 18. And some of the students, I think I'm getting them for the first time in my class, like Ibtisam. Ibtisam, is this the first time you're having a class with me? My goodness. Because this is the first time I can see her in my group. Okay, what to do? Now, let's go to that question. Hopefully you got it now, girls. Shall I start?
Wait, which question number?
7. Question number 7. Shall I start?
Miss, is
Yes,
it 41?
Yes, yeah, 41, May, June 18, question number 7. Okay, let's do it. State in terms of their structure why metals are good conductors of electricity. Actually, girls, this is a static electricity question, but they put it in this question, so we can do that, no problem, as we have already completed static electricity. So, do you remember what was that? Why the metals are good conductors? We have to discuss about the structure. Very good. Yes, Nashita, that's the correct answer. So, you'll be writing metals contain free electrons on their outer shell of the structure which can move. That's the answer. Metals contain free electrons on the outer shell of the structure. Okay. Now check the next part of the question.
Miss, outer shell?
Outer shell of this structure which can move. Outer shell of this structure which can move. It's a no, dear. Okay, fine. A cylindrical metal wire W1 of length L and cross-sectional area A has a resistance of 16 ohm. A second cylindrical wire W2 have length L by 2. Okay, and the cross-sectional area became 2A is made from the same metal. Determine the resistance of W2. So, do you remember that equation we had regarding the rho? That is the resistivity of a substance with rho and R, one equation we had. Do you remember? R equals to, what was the equation, girls? Anyone? We had the equation many times and we did the calculation as well. R equals to rho L by A. Do you remember that equation, girls? Nashita?
Yes.
Yes, dear. So let's do that. Yes, no, we have that equation. So first let us write down R1 because we have two wires. So first one we'll be writing R1 equals to rho L by A. This is the first one. So write down all of you. R1 equals to rho L by A. Now we'll write down an equation for R2. So we'll write down R2 equals, now guys, rho will remain the same because both of them are made up of the same metal. But the L will become now L by 2. So in place of L on the numerator, you'll be writing L by 2. Got it? And then in the denominator, you have to write down 2A. Yes, because they said they have changed it to 2A. So if you rearrange the equation, you are getting rho L by 4A. So write down equals rho L by 4A. Okay? Done, guys? Okay. Yes, dear?
Miss, can you repeat from the beginning?
Okay. First equation I said R1 equals to rho L by A. This equation everybody knows. Then I'm writing another one for the R2, means the second wire. That is R2 equals to rho. On the numerator, in place of L, I'm going to write L by 2 because they said they have changed it to L by 2. And in the denominator, in place of A, we'll be writing 2A. Then if you rearrange, you are getting equals to rho L by 4A. Okay, guys. Just rearrange that 2 on the numerator, that is L by 2. That comes as a denominator 2. So it will be multiplied with the other 2. So rho L by 4A. Now this rho L by A is actually nothing but the R1 resistor. And that is 16. So we can write equals to 16 divided by 4. Equals to 4 ohm. You have to show all these steps here. It's 2-mark question. So equals to 16 by 4 equals to 4 ohm. You know, that is why we wrote the equation initially R1 equals to rho L by A. We have to write down the equation initially.
Miss, I didn't understand.
Shall I repeat? Which part you didn't understand? Say, Ashita?
I don't know, what did you say after rho L by 4A?
Yes, then you'll be writing 16 by 4. You know why? Rho L by A, that is the R1, and R1 is given in the question as 16 ohm. So rho L by A, we are writing or substituting the value of rho L by A, that is 16 divided by 4. So the answer coming up, 16 by 4 equals to 4 ohm. Done. Done, guys? Shall I proceed to B2?
Yes, Miss.
Okay. Now, check the effective resistance of W1 and W2 when they are connected in parallel. So definitely we have the equation 1 by Rp equals 1 by R1 plus 1 by R2. And one is 4 ohm, another one is 16 ohm. So just add it and give me the answer. It will be 1 by 4 plus 1 by 16. Check in your calculator and give me the answer. Do. I'm waiting. If anyone got the answer?
3.2.
I think so. Yeah, say. Asil?
3.2.
3.2.
Yes. Correct answer. 3.2 ohm. Don't forget the symbol of
Yes.
ohm. Yes. Because that's the unit we have to write it. I hope the rest of the girls can follow me. Okay, I can see. Let me see it right here.
Miss, what is the answer again?
3.2 ohm. Okay. Nafisa, did you complete the calculation? Tazrian, you got the same answer? 3.2 ohm?
Yes, miss.
Okay. Nafisa, I don't know why she is not responding. Okay, fine. Now, I hope Noshin, you are following my class. Noshin, are you there? You got the same answer? 3.2 ohm?
Yes, miss, I did.
Okay. Now, let's go to part C of the question. The parallel pair of resistors is connected to a battery that is made from 3 cells in series, each of electromotive force E, capital E. So, there is a current in each resistor. State the EMF of the battery. Someone give me the answer, please. Read the question one more time and give me the answer. I want to hear it from you girls. See, they said one of the EMF is E. They did a connection with 3 cells. So what will be the total EMF of the battery? Now it became a battery with 3 cells. Someone from the class, give me the answer. Anud, could you help me? If EMF is E for 1 cell, you have to check the battery which consists
9.6.
1.6 here. Why? Where did you get this point? Where did you get these numbers? See,
I
this.
don't know.
Volt into 3.
Yes, Anu, tell me one more time. I couldn't hear it clearly.
Voltage into 3.
Why the voltage here? Because they said you have an electromotive force E. It's a symbol they gave you. So, what is
Shouldn't it be 3E?
very good answer, Noshi. Yes, I think Anu was trying to tell me that one, but she couldn't give me the proper answer. Because we have electromotive force for one of the cell is E. So 3 cells, 3E. Done. It's not that all the time you have to have 1.5 or something. Okay, it's just a symbol they gave us. We're going to continue with the same symbol. Even though we know that a cell can have, the dry cells can have 1.5 volt, but we don't need to mention that. We straight go with 3. Done. Okay, now let's check that. The current in the battery is IB. The current in the,
Answer
which one here?
C1.
C1 is 3E, capital E, because they said one of them is E. Okay, now I am in C2, check. They said the current in W1 is I1 and the current in W2 is I2. So we have to show a relationship here. So look, let me see here is I2, right? I2, what is the resistance here? I2 is 4 ohm. Okay, 4 ohm, so it will get more current. Okay, guys, what is your suggestion? Which box we should take? All of you check all the relationship they have given to us. You have to pick one of the box. So which one you think that it will be the correct answer? Before that, you need to remember what was the procedure of current there in a parallel circuit. The current from the source will come out and it will get branched in 2 parts because we have two resistors connected in parallel. And each resistor, the one who's having more resistance will receive less current. The one which is having less resistance will receive more current. This is the explanation of the parallel circuit. So according to that, which one you feel that will be the correct answer? Anyone can give me from the class? Okay, Anur, could you give me the answer there? Or Afnan Abdul Kadir? You can try. Let's see what comes up.
This is the second one, Miss.
From the top, second one. Actually, it's not correct here. Could you check more?
Miss, is it the first one?
No, dear. No, dear. It's not the first one. First of all, you have to remember the current that is coming out from the source will be the largest one. Definitely. After that, it is getting branched.
The sixth one?
I think so. Second last one you're talking about, right, girl?
Yes.
Yes, that is the correct answer. Because IB, the one which is coming out from the battery, will be the largest. Then it will get branched. And when it is getting branched, think about W1, it is 4 ohm. So it will be getting more current. So IB will be greater than I2. I2 is how much? W2. W2, how much? We got 4 ohm. Yeah, W2 is 4 ohm. So it is having less resistance, more current. So I2 will be greater than I1 as well. So IB is greater than I2 is greater than I1, which means the second last box you are going to tick. Clear? Okay. Now let's go to 42 variant quickly, girls. I want to do more. Let's see which question we do have here. 42, May, June, 18. Okay. Yes. We have a question number 8. All of you quickly move to 42, May, June, 18. Okay. Now, by the time I want to take your attendance today. Okay. And girls, you'll help me. Like Afifa is present, Afnan Laiba present, Afnan Kader present, Anur present. Anur is also there. Asiya is not here. Asi, I can see. What about Fatima to Zora, girls? Is she here? I don't think so. Right? No, she's not there. Okay. I can see Ibtisam is present today for the first time in my class. Ikra, is she here, Ikra? I think I have seen her. Ikra is here. Okay. Then Kaziwata is here. Marwa Zaman, I think I haven't seen her. Reem, I don't see her. Mukarrama is here. Muntaha, Nafisa I have seen. Nashita is here. Dimra I saw. Noshim is here. 1 minute here. Reem is here. Okay, fine. Reem is here. I can see that. Okay, fine. Then Rahma, I have seen her, I think. Yeah, she is there. Okay, then Sadia Hassan, I don't think so. Sadia Irfan, Sumaya Mahbub, I think she's present, right, girls? Sajda Noor is there. Sarah Islam Shahad, I don't see. Luzain is there. Habiba Almas, I think Habiba is there. Does Yanfa, I didn't see. Girls, is Yanfa present? No, I don't think so. No, she's not there. Okay, fine. It is supposed to be 23. Okay. Done. Now, so I hope you got the question here. 42, May, June 18, question number, that is 8. Okay. Now, all of you look at the circuit they gave to us. Shows a circuit that contains a battery of electromotive force 6.0 volt. Okay, fine. An ammeter, 20 ohm resistor, and a component X. Okay. First, they told you to write down the name of the component X. Someone give me the name of this component X.
Variable resistor.
Yes, it is variable resistor or rheostat you can write. You know that, right, guys? We can write it as rheostat. R-H-E-O-S-T-A-T. Rheostat, variable resistor, both the way it is correct. Sadia Hassan is coming now. Late. See, when I'm calling your names and taking your attendance, if you're not there, I can't give you. And you know, for your final term result. Okay, guys, let me finish one thing. You saw the that information in your group that as we are not going to have any final exam, your presence in the class, your participation, and everything will denote your final term result. It has to be an estimated result. So make sure that you are in the class. Yes, dear. Who was asking me something?
The question number, what is
Yes.
it?
That is 42, May, June 18, question number 8. Okay, guys.
Okay.
Now check A2. The potential difference across the 20 ohm resistor is measured with a voltmeter. On the figure, draw the voltmeter. Now, how will you draw it?
would be in parallel connection below 20 ohm.
Actually, we don't say the word below, we have to say across. So you'll be drawing it across and with a circle with a V inside. That is the symbol of a voltmeter. So all of you draw this one. And you know, surprisingly, this thing you're doing in paper 4 and in paper 6, you have to do it many times. It's a very common question in paper 6. And hopefully after completing it, I have to do paper 6 with you. Okay.
Where will draw the voltmeter again?
Across 20 ohm resistor in parallel. Remember that it has to be in parallel. Okay. Now, the PD across the 20 ohm resistor is varied from 0 to 6 volt. For each value of PD, a corresponding current is measured. Okay, fine. Now, come to the other side of the page, page 30. On figure 8.2, draw a line to indicate how the current measured by the emitter depends on the PD across 20 ohm resistor. Okay, fine. Here, 3 marks is given for you to understand. You have to go for some calculation, then the plotting will be. So, if you just look at it, the grid that they have given to you, in the y-axis we have the current I, and on the other side, the x-axis we have the PD, the voltage. It's a VI, we say VI curve or VI graph. So, in our equation, just go back to the question, starting question of B. They say the PD is 20 ohm. PD across the 20 ohm resistor is varied from 0 to 6 volt. So what is the highest value, girls? 6 volt, isn't it? According to the question? Yes, fine. And then they are saying that, okay, so if I take in my grid, in the potential x-axis, potential difference or x-axis, 6 is the highest value given to me, isn't it?
Yes.
So I have to find out the corresponding current I. So let us use the equation. You can do it in that page number 12 at the end of the page. You do the calculation there. We know the formula V equals to IR, the one we call Ohm's law.
Yes.
Okay. From there, I want you to find out I. So I equals to V by...
0.3.
Yes, fine. Yes, it is 0.3. Show the calculation here. V by R. First you write down I equals to V by R. Then what is your V? 6. And what is your R? 20. Then you got the answer 0.3 ampere. Got it? Now you come to the grid. All of you come to the grid and 6. Wherever we have 6, the end of the grid, go up on the point of 0.3 ohm. Sorry, 0.3 ampere. Highlight the point and from 0, just join it with a straight line. So this is your graph. All of you do it, please. From
Miss,
6,
can you repeat?
you have completed the calculation. Asil, you got
Yes,
0.
ma'am.
Fine. Now come to the grid. Wherever you have 6 volt, means at the end of the grid, wherever it is written 6, you just go up to 0.3 ampere and put a dot at that point. Put a point. That is our highlight point. And from that point, you'll be joining to origin, to 0, 0, 0.
Okay.
Got it? So this straight line is nothing but this curve of this particular resistor 20. Got it, girls?
Wait, Miss, the line, it's gonna be horizontal?
No, dear. It's straight to the origin.
Okay.
That point will go straight to origin because we have started the voltage from 0 to 6.0 volt. They mentioned it, that we varied it from 0 to 6.0 volt. Okay, I hope the rest of you could finish this question. Then only I'll proceed to part C of the question. Good. Let's do this. A second resistor is connected into the circuit in parallel with the 20 ohm resistor. And you know, girls, this is one of the very smart questions that I found till now, especially the recent years. It's a very important question as well. So C1 check, they wrote, say how the combined resistance of the two resistors in parallel compares with the resistance of each of the resistors on its own. Now, you can understand this question.
The combined resistance of the two resistors in parallel is smaller than the smallest resistor.
Resistor connected in the circuit. Very good answer. Remember, we had this point I discussed with you in the class when I was explaining that this is so important. Sometimes a question will come for this one. So this is the one I was referring to. Means the point that I wrote over there, that is the statement. What will be the combined resistance of a parallel circuit? That statement you have to write here. So you'll be writing the combined resistance will be less than the smallest resistance of the resistors. Smallest resistance of the resistors. The combined, even though it is 1 mark, but you have to be clear. The combined resistance will be less than the smallest resistance of the resistors connected in the circuit. Resistors connected in the circuit. Done, guys? Shall I proceed to next part, C2? Okay. Now, all of you read the question.
Wait, would you repeat it again?
The combined resistance will be less than the smallest resistance of the resistors, connected in the circuit. Connected in the circuit. Then the okay. Now all of you read out C2. The PD across the two parallel resistors is changed and the current in the battery for each value of the PD is measured. Okay. A second line could be drawn on the figure to indicate how the current measured by the ammeter depends on the PD across the two resistors in parallel. See, now that combination is in a parallel circuit. They added another resistor along with it and they calculated the same thing. So they are asking what happens over there. State how the second line differs from the original line. You are not expected to draw the second line. You don't need to draw, but you can give us an idea what you expect it to happen. Will it be a line which will have which will be above it or below it? Could you give me an idea? What do you think? What will happen to the current of the circuit when you're drawing like this? Because already we had the graph with one single resistor. Now they have given a parallel one. Okay, there are two parallel.
A line below it.
Okay, your idea, it has to be below. And what about the other students?
It will be more steep, like above it.
It has to
Wait,
be.
yes.
Yes.
I think it will be above.
It is above. Because you know why? When you give connection to the parallel circuit, the total resistance of the circuit gets decreased. So resistance get decreased means what? Current gets increased. So it has to be a line above it which will have more gradient and it will be more steeper than this particular line that we already have. I hope you understood the explanation, girls. It has to be a steeper line because, and why I am coming to that conclusion? Because when you give a parallel connection, the total resistance of the circuit gets decreased. So definitely current will get increased. So let us write down, as circuit resistance decreases, current increases. So the graph will be steeper with higher gradient. So the graph will be steeper with higher gradient.
Miss, can you repeat the beginning?
Okay, I said if, okay, let's start. As circuit resistance decreases, current increases. So the graph will be steeper with higher gradient. Will be steeper with higher gradient. Fine. Now, all of you quickly go to 41 October, November 18, question number 9. Quick.
Miss, I'm sorry, with higher?
With higher higher gradient. Gradient will be steeper and higher with higher gradient. Sorry, will be steeper.
Thank you, Miss.
Now, all of you go to 41 October, November 18. Question number 9.
Doing 43 May, June 18.
But most of the students don't have there. That's why I'm not going for that. If you have, just try it and send me. I can check the answer.
Okay.
After completing, means after solving, send it to me and check. Okay. All of you go to 41 October, November 18, question number 9. Okay. Now, if you just look at it, they have given us a part of the circuit. We have to draw it actually. They say the two lamps are connected in parallel with the battery using the correct symbol. Complete the circuit diagram. I think most of you can do it, isn't it? From the battery, the two lines will come down and you draw two lamps in parallel and give them a common connection. I think everybody can do that. Can you do that, girls? I think you can do this, right? Okay. Now let's go for, yes. Yes, you're going to bring the two connection from the source or the battery down, and then you make a block where you're going to give the connection of the two lamps in parallel. And of course, the lamp symbol is a circle with a cross in the middle. Right, girls?
Yes.
Okay, fine. So do that, and then I can go to question number B and C quickly. Okay, in B they say calculate. Okay, one of these lamps has a resistance of 6 ohm. Calculate for this lamp. What is the current? Okay, so we know that in parallel circuit, voltage remains the same, current gets divided. So I can straight use the equation I equals to V by R. Voltage is 12 and resistance of each lamp is 6. So what is your answer? I equals to V by R, then 12 by 6 equals to 2 ampere, isn't it?
Yes, it's 2, right?
Yes, 2 ampere. Okay, now let's quickly do the next part. They said you have to calculate, yes dear, 2 ampere, the first part of the question. Now they said you have to find out the power. So what is the power? P equals to VI, we know the equation. So now you can just use voltage is given, now, right now you got the current. So what is the power?
24.
24 watts. Correct. Okay. Now the power of the other lamp they are saying is 36 watts. Calculate the total energy delivered to the lamp in 20 hours. Okay, we have the equation, remember, E equals to PT,
Yes.
power into time, so use it. But do remember the time has to be in second. So keep on converting it till you reach second because it is given in hours.
We'll add the powers, right?
36 watts they gave us. So multiplied by 20 hour, multiplied by 60, it got 2 minutes. Multiplied by 60, it will go to second.
129600.
Tell me again here.
129600.
No dear, no dear. No dear. Did you?
Is it 43200?
I don't think so. Could you check it again?
Is it 2592000?
I think that is correct answer. So just make it 2.59 into 10 to the power 1, 2, 3, 4, 5, 6. Is it, Nashita? 2.59 into 10 to the power 6 joule. I got 6. Just check.
I did not get that.
Listen. E equals to PT.
Yes.
Yes. P is 36. They gave power of the question. In this question, don't use 24 dear. It's 36. We're talking about the other lamp. So 36 multiplied by 20 hour. Again multiplied by 60. Multiplied by 60 because we're going to second. Then you'll be getting 2.59 into 10 to the power 6. I hope you got it now. Got it? Okay.
Miss,
2.59. Welcome back, girls. Did you hear me?
Miss,
Yes, dear. I'm here.
I got 2.59 multiplied
10
by
to the
10
power.
to
It has to be 6. Check. 10 to the
yes, 6, miss.
Yes, fine. Done. Now, all of you go to 42 October, November 18. 42, October, November 18, question number 7. All of you go to that. Question number 7. Did you find? There is 3 lamps in parallel. Yes, and an emitter and a source is given, power supply is given. You got that? Very good. Now let's start doing this question. Did you notice that mostly we get combination circuit, or sometimes they give us absolutely a parallel circuit. So you have to understand all the basics of these circuits. So then you can just get all the questions done by yourself. It will not be a problem for you. Means understanding the circuit is a must initially. Okay, now check. They say in question number 7, did you get the question, girls, or shall I wait for you? Did you find it?
Yes, Miss.
Okay, fine. So let's do this.
Can you repeat?
It's 42, October, November 18. Question number 7. Now, just check all of you. They say here, if you notice that they have given 3 branches in parallel circuit and they have 3 different switch is there. So it means that individually we can switch off or switch on all the lamps individually, isn't it? So let's see. The switches are closed. Okay, all the switches are closed now. Each lamp is rated to 60 watt and operates at its normal working voltage of 110 volt. Fine. Calculate the current in each of the lamps. So we have the equation P equals to VI. From there, find out I, girls. Go for the equation P equals to VI. And from there, I want you to get the answer. Could you check? 0.55 ampere. Correct. I hope all of you got the same answer, girls.
Miss, I got 0.55.
Correct. 0.55 ampere. Now, I want you to go for the next part of the question. They said, okay, they said that, the current in the emitter. Now, all the lamps are identical. So, don't you think we can consider that all of them are getting the same current? Can I say like that, girls? As they are identical?
Yes.
Okay. So, what will you do? Just multiply by 3 and
Multiply
get the
by
answer.
3.
Very good. Just multiply by 3, nothing else. Because altogether, it will be the total current. So, multiply by 3 and see what is coming out?
1.65 ampere.
Okay.
1.65.
Okay, make it 1.65.
1.64.
Okay, write down whatever you want. 1.6465 ampere. Done? Okay. Now go to the
Miss,
next.
we can also add 1.7.
I don't think so. Keep it 1.65. No problem. We can continue.
Okay.
So next they say the voltage of the power supply. Okay, so we can go back to the equation one more time. P equals to VI, and from there you find out V. V equals to, then it is becoming P by I. V equals to P by I. Make V as the subject. So V equals to P by I, and what is your power, girls, now?
60. 60.
60 multiplied by 3, because 3 lamps are all together. Right? So P will be 60 multiplied by 3. Don't just use only one, then it will be only one lamp. But here we have 3 lamps connected in parallel. So 60 into 3 divided by 1.65. And check what's the answer coming.
109.1.
Okay, so it means that they told us that that was supposed to be 110 volts. So it's correct. 109 means 109.
Wait, I didn't understand. Can you say again?
100 point. No.
No,
Is it
listen to me.
110?
Is it? Okay, fine, no problem. Decimal difference is not a big deal.
Please, I didn't get a decimal.
Okay. So actually what we are getting, let me check with the calculator. 60 into 3 divided by 1. 60 into
I got
3.
109.09.
Okay, write down that one, no problem. 1.65. Okay, I'm getting actually 109.09. Okay, we can continue. 109.0, that one you can continue, no problem. 1.65. Yeah, fine. Continue, no problem. Okay. So final answer is 109 point. Say girls, how much you got? Let me match with mine.
Okay.
Huh? 109 point. What you got there?
109.09.
Yes, 109.09. Okay. So we can write it, no problem. Okay, fine. So let's go for the next part of the question. Turn the page. Check, we have another part of the question. In page number 15. Calculate the resistance of the filament of one of the lamps when working normally. Okay. Only one of the lamps they're asking. So, I'll do one thing. We know the formula V equals to IR. So, R equals to V by R. Okay. So, your voltage is now 109.09 and the current we got 0.55. Check what is the answer coming up. 109, let me calculate as well, divided by 0.55. So, I'm getting, girls, how much you got? I got
198.3.
Yes. Okay, fine. So, 198.3 and final answer, you can just write down 198 ohm. 0.3 we can omit. Right? So, it will become 198 ohm. Fine. Now, B2.
Miss, can you repeat the calculation for BI?
Okay, that is R equals to V by I. You know that V equals to IR from that equation. R equals to V by I. Right now you got V as 109.09 and divided by I. That is 0.55. We are getting here around, I think, 198.3. So we can continue with 198 ohm.
Okay.
Now check B2. Another lamp X has a filament with twice the resistance of each lamp in the circuit. Okay. The material and the temperature of the filament in lamp X is the same as the filament in the lamp. Yes, dear?
The question A3,
Mhm.
we have to find the voltage of the power supply. Well, it comes around 110 and it's already in the question 110 volt. Why did we calculate?
No. Just that is, listen, 110, that is not the source voltage. That is the voltage given for the lamp to work normally. The lamp needs it. Did you
Is the
understand?
voltage same?
No. That voltage is not for the power supply. They say this amount of voltage is needed by the lamps to work normally. Got it? So after doing the calculation, we got 109.09. So that is really close. That is why the lamps can shine. Did you understand? Okay. Now check, I was doing B2. They told us that, okay. In the table, check any box in the right-hand column that shows a possible difference between the filament of lamp X and the filament of one of the lamp in the circuit. Okay, they say here what the resistance should be twice the same, right? So, which one are you going to put tick?
The second one.
Yes, and then let me see. Okay.
Fourth one.
Yes. Area should be less than half of this one. Yeah, correct. Second and the fourth one. Yes. Has the same filament and there is the twice the resistance. Yes. So it will be the second and the fourth box you have to put a tick. Right? Okay, fine. I think we are done with this question and we don't have any more over here at this moment. So tomorrow, girls, as I said, if you can download 41, 42, 43, May, June, and October, November for 2019, then I can check with you those questions tomorrow. But since I have around 15 minutes in my hand, I want to go to the electromagnetism chapter. So at least I can have 1 or 2 topics with you. What do you say, girls? How many of you have completed writing this note?
Miss, I still have some to write.
Okay, no problem. Continue because we have time. Don't worry about that. So
Okay,
let's
and Miss,
see.
please don't forget to reset page number 2.
Yes, yes. Okay.
Thank you.
Now, you're welcome. Now let's see. I hope you can see this page, first page on my note. Can you
Yes,
see?
Miss.
Okay. Now you tell me in second page, which point you have a doubt. I'll discuss that one and then I go back from the beginning. Could you see on the screen where you have the doubt that you couldn't understand? You told me. Asil?
No, Miss, it's just like there's some words which I couldn't
Okay,
understand
fine.
or maybe read.
Okay,
That-
fine. I'll start, then you can follow me, right? Okay, guys. Now let's do. As I told you, that electromagnetism will be a big chapter, and if you follow the past paper questions, almost every single year we do have a question from there, right? So you can understand the importance of this particular chapter. And here you remember we have less amount of equation, more amount of idea. You have to understand it clearly. Your idea has to be very clear to answer all the questions. In paper 2, paper 4, paper 6, we don't have any question regarding this chapter, but we have paper 2 and 4. Every year we have questions. Okay. Now let's check. First of all, I wrote it here. Electromagnetism, what is this? First, you have to understand one thing, that whenever we pass electricity to any substance, whatever the substance is, of course, it will be a conductor. Otherwise, how can we pass the electricity? Then some changes we can experience there. Means what are those changes? See, point number 1, I wrote lighting and heating effect. Like lamp is there, it is giving us the light. We provided electricity, we are getting light energy. And heating effect. If I say electric heater, you can easily understand. You are providing electricity to an electric heater, it is giving you heat. Then I wrote chemical effect, that is electrolysis. This one you have discussed in chemistry, I don't need to discuss. You will just remember, after giving the electricity or passing electricity to certain liquids, it is going to divide into electrolyte. It will be dividing into positive and negative ion, cation and anion. So that is electrolysis. We'll not discuss it. But we'll go for the next point, that is called magnetic effect. That is the one we call it electromagnet. It means that if you pass electricity through a certain substance, of course it has to be a conductor, then it may turn into a magnet and show some magnetic behavior. So we call it magnetic effect, and it is nothing but the electromagnetism. Okay, now let me continue. Look at the next point that I wrote, magnetic effect of a current carrying conductor. So what do we mean by this? It was found that if you have a simple wire which is passing, which is nothing but a copper wire, and it is having electricity through it, or it is passing electricity through it, it was found that it will behave like a magnet, or it will create a magnetic field around this wire. But just because it is passing electricity through it, or it is allowing electricity to flow through it. Now, I'll just give you an example that how is it possible that it behaves like that. I will give you one idea. Sometimes you might have noticed, think about in your home, the television is functioning, means it's on. The television is on in your home, and someone came in your home and they pressed the doorbell. Did you ever notice that some disturbance happens in the screen, on the screen, or the picture gets kind of blurred, or some disturbance will occur on the screen of the television? Did you ever notice that, girls?
Yes, Miss, it usually happens.
It does happen like that. Just because I'll tell you, when they press the doorbell, there is an electromagnet. So that magnetism of that one and the magnetism of the television do have an interaction. Now you might be thinking, how is it possible that a television is having a magnetism? It does have, because it is passing electricity through it, so it is going to create a magnetic field around it. And if there's another object which is also having a magnetic field, and they come closer to each other so that they can have an interaction, that way we can see this blur scheme or some disturbance on the picture of the television. Now, if you just look at my diagram, the one I shared with you right now, there I have shown you two diagrams, A and B. First I wrote When current flows through a conducting wire, a circular magnetic field is produced around. Now, how do I know it will be a circular? Just if you look at it, the box stacking that I drew, you can consider it as a cardboard. The copybook that you have or the record book, there's a cover like a thick cardboard, I mean. And I'm going to make a hole inside in the middle of it and then pass a wire that is nothing but a copper wire. And the two end of the wire, I'll give connection to a cell or a battery. If you just look at my diagram, I have given a battery. And then I will pass electricity through it. After that, how will I know there's an electric field created? I can do one thing. I can just sprinkle some of the iron fillings on the top of that card and tap the card few times. After tapping it few times, you will see that all the iron fillings are going to arrange themselves in a circular way, the way I gave you the diagram just beside it. But you'll never be able to know the arrow. The arrow that I gave you on the diagram is showing the direction of the magnetic field. That one you'll not be able to see. After tapping the paper, you can see the circular arrangement of the iron fillings. It means that there is a magnetic field which is actually allowing these iron fillings to arrange themselves in a particular way. Now, if we just look at both the diagrams, on the top A, I wrote when the current is into the page. What do we mean by that? And let me remind you, in this whole chapter, we are going to follow the conventional current flow. Now, who can tell me what is a conventional current flow? Yes, girls, I taught you this one.
It passes from the positive terminal to the negative terminal.
Very good. Just look at the diagram. Did I give the arrow from positive to negative? In A, I hope all of you can see on screen my diagram.
Yes.
Is it yes, fine. Is it the way that I taught you that it has to be from positive to the negative? Okay. So I'm saying is into the page. So what is the page? That cardboard or the paper that we're discussing. You remember, this is so important. Here, all the time we'll be writing into the page, out of the page. So you need to know what is into, what is out. So when the arrow is going into, means if I have a horizontal paper or a cardboard and the Y is going through right through it, then it has to be into the page. Means the connection will be the way the diagram is given. Then it will be, see the diagram that I gave you, I drew a circle in the middle with a cross in the middle. This cross is so important. You remember cross means into the page. These are the symbols, girls. So you need to understand it very carefully. And then I drew some circles. Now I want to ask you a question. Girls, did you notice the way I drew the circle means the two patterns of the magnetic field lines? Did you notice one thing, that the gap between the lines from the center keeps on increasing? Did you notice that?
Yes, miss.
Yes, this is so important because they will be giving you 3 marks for drawing this diagram, one diagram. And how will they mark the paper? If you draw the diagram like this, first they'll check whether you give the symbol of into the page or out of the page correct or not. Then they'll check whether it is a circular lines that you drew. If it is correct, then they'll check the arrow. And then finally, they'll check the gap between the two lines. It has to be increasing. Think about the first gap, you kept 0.5. Second gap has to be 0.7. Then 1 centimeter, like this. It has to keep on increasing. And they'll give you a huge space on the past paper to draw the whole pattern. And it is of 3 marks. That is why it's so important for you to understand. Okay, fine. Now come to the next point that I wrote.
Miss, can you explain why is it increasing?
I will come to that one. Hold on. That is the property. I'll come to that. Right now, you'll remember it has to be having an increasing difference between the lines that you're going to draw. These are all magnetic field lines caused by the current carrying wire, you can say. Okay. Now check the B part, guys. Here I have shown
Miss,
you.
the gaps between the lines should be increasing.
Exactly. If you just look at the diagram, you can understand. The gaps between the line keeps on increasing. As you go further from the center, it will keep on increasing. Now check part B I wrote. When the current is out of the page, if you just look at the diagram, you might feel that the diagram is exactly the same. But just look at the connection of the cell or battery, then you'll understand. I just changed it. Now again, it goes from positive to negative. So as I gave positive as the down line, From there, it is coming out of the page now. So if you just look, I gave the arrow out of the page. So I wrote, when the current is out of the page. This is so important. Understand the difference between these two things. When the current is out of the page, and look at the diagram, I drew a circle at the center and a dot in the middle. I don't know, somehow it seems like two dots. No, actually it is a single dot. Okay? It will be a single dot inside a circle that represents current out of the page. Got it? And then again we are going to draw. But did you notice one thing, that in the first one, okay, now if you just see in the clockwise side, you can see all the arrows are given clockwise, I said. Means that is the one when the current is into the page. And when I go to the other side, I'm getting it anti-clockwise. This is the difference. And how do I know it is clockwise and anti-clockwise? We have a method. I'll be discussing it in my next class. But first check the two diagrams first. I hope you are clear about both the diagrams. You have to check the connection of the cell from where to where it is going, and it has to be from the positive to the negative. At the same time, we'll be checking the T symbol. Excuse me, who's that making sound? Could you mute your microphone? Who's that? Because I'm sharing the one, I'm not getting that. Okay, now listen. Who's making that huge sound here? Could you just mute your microphone? Yes, okay. So now we'll come to the magnetic properties. Okay, guys. Now let's check the properties of the this magnetic field, particular magnetic field. As I said, that this.
Miss?
Yes. Say.
Is there any difference between the dot and the X?
Cross. Definitely. Cross means into the page. Dot means out of the page. Okay. Yes. Okay. Now I think 1 minute. Who's giving me a message? Let me see what the. Explain. Okay, fine. Wanda wants me to explain again. So let me do that one more time. Iktisam, could you mute your microphone? It's creating noise. Yes, now listen. Okay, so as I told you,
Wait, yes, what do you specifically mean by page?
Page.
Yes.
Okay, as I told you, that you have page means our paper. It can be a cardboard, a hardboard. That is called the page for us.
Can it be a resistor?
No, how can it be? It's a paper. It's a paper.
Oh.
Okay, we are passing through. We are passing that wire, electrical wire through. Okay, we are passing it through. It is yes, I think she muted her mic now because it was making noise. Okay, now listen. So first of all, you have to understand here we are finding out or we are discussing about the two situations. First thing is that the wire is passing electricity into the paper. Second one, out of the paper. Okay, out of the paper. So in these two cases, we found that the pattern of the electric field, magnetic field that is going to be produced will have two different ways. One will have a direction clockwise, another will have a direction anti-clockwise. Okay. Okay, guys. So don't worry. Tomorrow I want to start with it. If you have your all the variants of 2019, you can collect it and I can do it with you in my next class. Or tomorrow I'll continue with this portion. Then next week, Wednesday, I can do the rest of the past paper question. What do you say, guys? Shall I do it like that?
Miss, will we do also 43 variants?
If you have, I can do that. But tomorrow, let us continue with the chapter. Then next week, again, I'm going to do the past paper with you. Okay? It will be better. So make sure all of you are collecting or downloading all the papers of 2019, whether it is May, June, or October, November. So that next week I can do that. But tomorrow I want to continue with this electromagnetism chapter. And all of you make sure you're writing all the notes on your record book because you have to study all these till your IGCSE. Okay? Okay, guys. Let me finish my class today. Stay safe. Inshallah, tomorrow we'll be meeting again. Allah Hafiz, guys.
Hi, Miss. Assalamu alaikum.
Wa alaikum salam. Allah Hafiz and bye girls.
Bye,
This
Miss.
means